Thank you very much, Ayan, and it's really a pleasure for me to be here today. I know it's a bit late, so I will be quite quick. So this is Berk, and I'm coming from Canberk University. So I have also a guest professorship position, like a visiting position, back in my alma mater, University, also in Northeastern University. And I mean, the executive summary that you see here is just for like last 4 or 5 years of digital twin research that we have been doing. And on the right side of the slide, you see the recent member of my lab. So we are having like we are getting bigger and bigger in terms of digital twin research. So we are focusing mostly on the real-time protocol design of digital twinning as well as this AI part of it. So we had some kind of nice discussion about AI for communication or communication or AI. So I can make like a little fun comment about that from my side that any conclusion will be good for digital twinning because we will need somehow smart data processing for digital twin, which is some kind of an AI for communication or communication for AI. We will also need real-time communication, which is going to be used for some kind of future forecasting for digital twinning, which is also good for us. So any conclusion for, in my perspective, is going to be good for digital twinning. So you know about digital twinning, so I will not go into detail because of time constraint, and I'm sure we all know about digital twinning. So one of the first questions I had been asked like 5 years, 6 years ago when I first jumped into that subject is the difference between the simulation and the digital twin. I'm sure now we are all aware of it. So in the digital twin, we are seeing what is actually happening, apart from the fact that we have some kind of simulation aspect with it. And one other thing that I really emphasize about this research area is that digital twin is just not about 3D data monitoring, 3D data rendering. It's also about several different types of complicated paradigms like two-way food-to-text communication. We have particular parameters like twinning rate, twin fidelity, age of twin, twinning index. Lots of particular things that are going on with this topic. And when we are talking about digital twin, we have to like divide the process into at least 3 layers. One layer is what we call like a data layer or physical space. So we grab the data. Here AI is with us, so we have to be as smart as possible. Big data is not that much important here, but smart data is important. In the second aspect, we need to like replicate our environment, which is one important aspect with us. So the communication 6G is with us here, 5G was with us as well. So we try to be as quick as possible with low jitter or I mean zero jitter or constant latency and all those things. And in the third layer, we have some kind of a service layer. Try to mimic the reality and try to give some kind of what if analysis, optimization, recommendation, and all those different stuff. So, as the name implies, twin, we have to have two screens. In one screen, we see the reality. This is not something new. We already have all those stuff previously, like 20, 25 years ago. And then we also have, like, as a new stuff, all the service thing, which you can have like simulation, button scenarios, optimization, all the different types of AI magic. Okay, so what is merging is the digital twin. Imagine that now we have like we can just have a digital twin of this room, so you can see me in a digital environment, which is good. And at the same time, in the second screen, you can see me 5 minutes from this particular moment. What if I start singing? What if I start jumping? What if I start dancing? This type of anomaly, abnormal situation can be done thanks to digital twin. So this type of particular scenarios are really one of the topics that we have been really discussing. For example, instead of actually building a wind farm, what about doing the digital twin of it? What if a wind farm would be here? What type of energy consumption? What type of any other use case specific parameters that you can adjust if that situation would happen? This kind of services are the main topic of digital twinning. And where are we? We are trying to make the real-time communication protocol stack of this entire framework. And then we have a particular digital service platform like the cloud. So you can directly pop up with the new services, new digital twin, and then come up with different types of scenarios. I will not mention about this. We are all aware of the fact that digital twin is really one of the hottest topic is going to come in the next 3-4 years. So from this slides, like 6-7 slides, I will be really quick, try to summarize the project and the papers and most of the projects that we have been through. This is our very own real-time like protocol stack, digital enabled protocol stack, communication stack for smart cities. So the main idea, the research question was how to serve two-way or two-synchronized digital communication. Because of the fact that the traditional Internet of Things deployment, several protocols cannot be directly utilized to collect operational and configurational data in 2 ways. They can collect data, obviously, but the data that we need should be quite quickly analyzable. And this some kind of bring a challenge to us. So we come up with a new data modeling using the young, yet another next generation model. I mean, this is also the existing one, but we use this to manipulate and to come up with a new model, and then come up with a full synchronized protocol. This was one of the projects that we have been through. Another one is like the digital twin aided green mobility management for next generation transportation network. The main idea was to lower emissions on road transportation network by controlling the traffic flow. So we have, as you see, we have again 3 layers here. One, the physical twin layer, so you have the reality, and then we have the digital twin layer that you mimic the reality. How we do that? We are using knowledge graph. Here, there's an interesting thing that I will mention so quickly. Usually, the knowledge graph or any type of ontologies are not suitable for real-time analysis, which is interesting. So we try to make them suitable for real-time by like making different types of graph search algorithms and making them quite like lower complex. And in the third layer, we have a service layer, meaning that you can have a machine learning model, try to come up with a new emission model. This is one for the vehicle networks, which is the research question here is which is the best deployment framework for vehicle digital twins. You can put your digital twin framework into the cloud, into the edge, or into the environment hybrid manner. So which one is better? Under which circumstances was the main question that we have been asked, and we try to like make different types of offloading mechanisms from this moving devices, and then try to offload data gathering from devices to the edge server or to the cloud server, and to come up with an optimized digital twin by optimizing the twinning index, by optimizing the age of twin, and then I mean this is co-founded by the different types of unions. Say this is some kind of a romantic project to me because it started after you know about this. It started like 6-7 years ago when I was an IT youth in Turkey. It was like a drone, like flying base station project. We were not aware of the fact that we were doing this at that time. Us together here, we have a laptop. It turns out that this laptop is a digital twin. So what is the idea? The idea is as follows. So we had several drones, okay, and then we were trying to deploy them in a stadium and try to come up with different types of scenarios in another screen, which is a digital twin for us, but we didn't know at the time. So we were saying that if these drones were keep flying like that, and if this drone like they were having instead of 3, if you put another one, the coverage area can be maximum, can be minimum. So one of the drones should be altered effectively, so you can make it down, you can make it up, you can change the altitude, you can change the attitude. These different types of commands can be given thanks to this laptop, thanks to this digital twin So we can come up with a complete optimized coverage area of particular regions with this algorithm. So this was like an NRQA swarm deployment for drone base station, and we have a new project actually. This now we call it a digital twin enhanced approach. This is a digital twin platform for 6G run emulation. We try to make an emulation environment like an emulator in real time in order to check how scalable test environment for 6G run. And we have different types of like models here. We use visibility, we use different configuration aspects, and we are of course using different types of containers here to come up with complete real-time run emulator. This is quite an interesting theoretical project that we still run. It's called network digital twins. We pop up different types of digital twin and to come up with a performance analysis. Here, the main reason for us is the lack of standardized performance metrics of any digital twin. And this makes the life really difficult for us because by network digital twin, I mean, I can have a digital twin of a laptop, or I can have a digital twin of a chair. At the same time, I can also have a digital twin of another thing. And what about these two guys in a virtual environment? They need to talk. So what type of real-time communication scheme you need to put on the scene in order to make them effectively communicate among themselves? So this brings us this network digital twin paradigm, and we were trying to, and we still actually, one of our PhD, she started to focusing on this. We are trying to make different types of data handling, data modeling, like interface capabilities and service delivery approach. Okay, so another project that we have been through is the real-time core network selection for planes, high-altitude platforms, tested in our digital twin as a service platform. This thing that you see here is one screenshot that we have in our platform. So what we do here is that we are using again real-time data from an open source. This is an open sky, and I think when I press this is moving. Yeah, this is just a small screenshot, small video that you can see at the time of this video recording, obviously. So you see here the map of UK, and then at the time of this video recording, you can see the real-time plane that are flying. In the first screen, you see direct mapping in a digital environment, which is like something not that difficult. At least there is no research done to direct the map. But in the second screen, you see some kind of a future clustering according to the data that we are gathering, and try to say that according to the data we have now, what if this plane can be gathered using a particular cluster? Why we do that? We are trying to recommend to the pilots or to the air control tower what type of antenna that these guys, each of this plane, can use in order to optimize their in-flight connectivity. I had no idea about this challenge. I mean, I am still using the internet connectivity plane, but I didn't know that each plane can use only one antenna during their flight to provide connectivity to us, to the passenger. I mean, they can use either their ground antenna or their satellite antenna or their ETOC antenna to connect to the other plane. So, which antenna would be suitable under which circumstances in the next 5 or 10 years? So this is kind of a digital twin specific topic. So we were dealing with that quite a long time, and then we have really nice results, and then 2 projects accordingly. This is a Royal Society project that we keep going about optimized air quality monitoring with a particular data modeling and using our digital twin approach. So the research question here was how to manage distributed sensors with different formats for effective air quality monitoring. And this screen, like a screenshot that you see here, showing us the reality and the future forecasting about the air quality at a particular region. This is another interesting one. Digital twin enhanced she enabled like just parameter based ship maneuvering, like the maneuver of each and every ship for effective naval operations. So the idea was to improve ship maneuvering in congested seaports. So in order to make them like approach as effective as possible without hitting the corners or increasing the possibility not to hit the seaport. So we were using different types of data sets and we were coming up with different types of recommendation scenarios in order for them to not to approach in a random manner or to not maybe do not approach at all or use particular sensors at a particular moment. This is an anomaly detection example that we also implemented to our digital twin as a service platform, which is called digital twin enabled anomaly detection for autonomous networks. As you see, we have lots of routers, and then we are collecting using Turkish Telecom real data actually, like different types of router data. And then we say that if this routers, that gate keeps or that port keeps having this amount of abnormal data, you may consider it to make it idle in the next 5 or 10 minutes. So we have a complete future map about this like autonomous network by checking the anomalies and try to detect them in advance, and then make a recommendation to the system saying that these routers and these gates can be closed down because there is a 95% of possibility to have an anomaly with that gate or with that router completely. This is my lab. These three ladies are particularly working in this topic, and in the background you see this platform. It's not that fancy; it's just a screen, as you see. But we have several screens to show in real time what may happen in the next 5 or 10 minutes. And we just recently got an award about this project in terms of a student project award because everything started as a student project, as you can imagine. This is the system architecture. Unfortunately, I don't have time to give the details, but I'm happy to discuss offline during the dinner. So we have 2 layers: data layer, virtual layer, and service layer, and we come up with different types of blocks like data part. The second part is mostly what we are researching because we are like computer engineers focusing on DevOps, like making the backend and the front end part. So we have data streaming and distributed processing as well as some automation of knowledge graph. This is the data streaming and distributed processing in real time. So we try to use like in-memory key, value store, or master data injection in order to make this distributed data processing in real time also. Knowledge graph is our trend here. I mean, it was not with us because it's really complicated for real-time communication, but we make it somehow available, and then we are using the knowledge graph in order to give us more flexibility, in order to give us more time to handle using our real-time communications. We are using in everywhere in our platform. And these are just screenshots. I have some videos that I will just pick up just to show what we have in the platform. And here, for example, this is a real test bed that we do in here. So we have some kind of sensor in the room. We are gathering the sensor. This is not so fancy, but we try to mimic the reality. I mean, yeah, it's running right. So on the first screen, you see the real time, which is at not 8 a.m. in the morning. So this is the CO2 heat map of the room because it's changing like frequently. And 3 hours from now at 12 o'clock, what may happen? This is the second graph. This is second monitoring. According to our like online AI tools that we are embedding into our platform, we can say that 3 hours from now, even though that particular area at this moment looks quite green, it may become red. So behave accordingly. This kind of recommendation and alert mechanism we are injecting to the system. A similar scenario. A similar scenario is done here for wind turbine or predictions. So here again you have two screens. Here you can see like the green one as the reality and the other line as the future, like the forecast of the energy. So here the idea is to predict the power according to certain circumstances. This is another one regarding transportation network. Try to understand how congested a particular road is, and again give some recommendations according to the analysis that we are doing. And these are different things that we are doing in the last 2-3 years. This is from 2 months ago. I was again here in this lovely campus, and I was visiting the London Digital Research Center, and I was giving a talk. So this is from that one, the last week. So that. And the last thing before I finish, we have two workshops. That one is in WCNC, the other one is the ICC. And we are, if you are working in this area, it doesn't have to be particularly children topic, but if you are working with smart data or some kind of CC communication related to this real-time part of it, you are more than welcome to submit your latest work. Being said that, it was me.